Okay, good morning. Glad as always to see a few of you here. I appreciate that you get up to join me for this every week. And hopefully that continues. I know not every week, maybe it'll work out. But anyway, as always, very much appreciated those of you who could join me live. Week 8. So next week is the midterm week. So this week's content will be in the midterm and everything up to this point and including this week. So weeks 1 through 8 will be covered by the midterm exam. The exam questions are a random selection of the first 8 weeks lab questions. So that's where you'll do your review. But anyway, next week, no new content, no discussion, no lab, only the midterm. And I will be here doing the live stream at 8 a.m. on Monday as I always do. But next week will be a review and that's all. Okay, so this week doesn't look like there's a lot going on. I added some extra detail, but basically we're just talking about processes and jobs. And that is, for a lot of you, this might be new stuff. So the concepts might be more difficult than a normal week where we are exploring a command and what it does with some text. So now we're actually using some tools that allow us to kind of view the status of programs that are running on our system. If you've used Task Manager in your Windows system ever, that is what this is for all intents and purposes. So let's, before I switch over to my virtual machine and just do those things, let's walk through this week's module. So again, next week, Monday morning will be the review for the midterm, and then your only assignment for the whole week is the midterm itself. It will be available to you on Monday morning and will be due by Sunday at midnight like assignments always are. So please prepare, allow yourself time next week to work on the midterm. All right, but we are in week 8, which means we're almost at the halfway point. So this week is processes and jobs. They are very closely related to each other, which is one of the reasons why this week's content can be a little bit confusing for people, is because getting it straight in your head, the difference between a process and a job, can be tricky at first because they are so very closely related. I'll just say right out, the process is the operating system doing something, and a job is the shell doing something to a process. But it is a little bit confusing because they are so closely wound up with each other. So readings as normal. I'll upload the lecture as normal. I'm going to go ahead and open up the hands-on experiments because I think probably there's some ideas in there that I can borrow from to make my life easier. So the lab is always, or pretty much always has hands-on experiments to help guide you through what can I do to explore and experiment with the concepts and the commands that we talked about this week. No new VI stuff. I will show you my RC file for Vim, but other than that, no new VI stuff, which I'm sure is welcome for almost everybody. VI is difficult. We had a good discussion about VI in our Piazza discussion this past week. And there's a lot of people in the world who just hate VI and will never use it unless they're forced to. And some people just love it. And it doesn't really matter which side that you fall on, or you just fall on the, I'll use it when I gotta, but I don't hate it. I just don't love it. All those things are fine. I use it when it's convenient to me, and I don't when I want other features in my editor. So when I'm doing programming, for me, typically anymore, I use an editor designed for programmers, not VI. That's just the way I found that I'm comfortable working. But when I do things that I want to be fast about, often there's system administration type of things, or I'm spinning up really quickly a script or something, I will often use VI. So I like having it in my toolkit because I can use it when it makes sense to me to use it. But I also like having other editors in my toolkit as well. Mostly about VI, I like the idea that there is no Linux or Unix system or anything derived from Linux or Unix that I can't sit down and be productive on, because they all have VI on them. In my experience, there's probably some specialized Linuxes out there that maybe have removed VI, but that would be unusual in my opinion. Okay. So the discussion this week is a kind of a light discussion as we're building up for the midterm, but hopefully we can get together and just kind of share our different approaches to preparing for exams. For some of you, this is an important skill to develop, because for some of you who are en route to being system administrators, preparing for bigger exams that lead to certifications is an important skill for you to develop. So I thought I would just sort of incorporate preparing for big exams into our discussion, because some of you, all of you hopefully want to do well on the midterm, but some of you actually need to build up your skills of exam prep as a part of your future career path. So that's why that's there in discussion. And then finally, lab this week, discussion this week, get ready for the midterm next week. And then at some point, probably next week is not a good time to do it, but at some point, please look at the distro project, which is the big semester-long project that is due in early December, but it is now approaching mid-October, so early December is a lot sooner than it used to feel like. Okay, little break on the voice. So let me switch over to my virtual machine and look at these things that are on our agenda. So okay. I always have a doubt that I'm going to remember that. So my VimRC looks like this. And I was kind of just borrowing what people seem to like in the discussion last week. So I always have set number on because I like seeing the line numbers. That's particularly useful when I'm doing any kind of scripting or programming work, but always just as a frame of reference, I like it. The ruler is typically on, you can see at the bottom that the row and column numbers are showing. I think show mode is on by default in Vim anymore. But that just, when you go into insert mode, show mode prints that on the bottom of the screen. And then cursor line, and I thought, oh yeah, cursor line is the thing that's highlighting the line that is the active line. So that's pretty cool. I did try color schemes. I just didn't love any of them. So I didn't find any color schemes that I personally liked beyond the default. So I ended up trying a whole bunch of different color schemes and decided I like the default the best, especially for teaching purposes. But I did think that the cursor line that lights up the line that the cursor is on, that's actually a useful feature. So I went ahead and enabled that. So there's my current Vim RC, which means those options are loaded into Vim every time I open it and run it. So there's that. All right, so now processes. So a process, simply stated, is an instance of a program running on your system. Right now, my operating system is running a lot of processes, as it turns out, but I can look at the processes that are associated with my activities individually as the JBoyd T user by using the command ps. So if I just type ps, that will show a listing of the processes associated with my user at the moment that that command is run. So the important process, bash, means that my shell is running because I am logged into the system and using the shell to interact with the system. And then the ps command popped up as one of our processes because the act of running the ps command caused an instance of that program to run. So a process is simply an instance of a program running on your operating system. That's all that it is. If you are, I think it's called Process Monitor maybe on a Mac. You can look at the Mac way of doing processes, and the Task Manager in Windows is the way in Windows to look at the way Windows does processes. So every time I run a program, there is a process, an instance of it running. And what's important to note for our purposes today is the PID column that you can see on the first column on the left, PID, and then it says TTY, and then time, and then the command that's associated with launching it. So PID stands for Process ID. And that process ID is important to us because it is a way for us to control processes. So if we have the process ID, the PID, we can use tools to control those processes as commands and in our shell. All right, so I have two processes. It turns out that one of those processes ran and exited the moment that I ran it, the PS process. And if I run it again, what we'll notice is that the same bash process is still running, and I know that because its PID is the same, 442. But it was a different instance of PS that had to run for this listing, so it got a different PID, process ID, 451. And every time I run it, I'm going to get a different instance of the PID for my command PS. Okay, so let's look at the man page for PS. It's an intimidating one, in part because just getting comfortable with what the concept of a process is intimidating. But also because it has a lot of options, and it has a lot of sort of duplicated options and a lot of optional ways of expressing options. PS is a very complex command, in my opinion. We won't dig super deep into it today, but using its manual page is a helpful way to begin to get some comfort with it. So PS, report a snapshot of the current processes. Makes sense. The thing that we're looking for typically is the process ID and the command, the name associated with it. Okay, so I'm just going to read aloud the things that I find interesting. PS displays information about a selection of the active processes. If you want a repetitive update of the selection and the displayed information, use top instead. I'll try to get the top command in there in the future, but if you want to explore top on your own, you're certainly welcome to do that. So notice here, this version of PS accepts several kinds of options. So this is sort of like optional ways of expressing options, which is unfortunate because it makes the command feel more complicated. But in terms of the options list that you can see in the synopsis, we have three different ways of listing options. We have the Unix style, which may be grouped and must be preceded by a dash. That's the style I tend to use. We have the BSD style, which may be grouped and must not be used with a dash. I guess I'll show you how those look. And then we have the GNU Long Options, which are the ones preceded by two dashes. So this is going to make this command seem more intimidating than it is. It's just, if I need to express an option, I have three different ways to do that, and I will show you examples of those, but then I use the Unix style myself. It's the short one. I'm used to typing the dash when I need an option, like ls space dash a. So that's the style of option writing that I use, even though the PS command supports three different styles. Okay, options of different types may be freely mixed, but conflicts can appear, which is unfortunate. There are some synonymous options, meaning that some of the options mean the same thing in the three different styles, which are functionally identical due to the many standards and PS implementations, etc., etc. So note that PS-AUX is distinct from PS-AUX. So that line there that says note that, and I don't think that you can see me. Yeah, you can. Note that PS-AUX, that's about midway down the screen, is distinct from PS-AUX. So PS-AUX is the Unix style of expressing options. PS-AUX is the BSD style. And it's telling you that in this case, these are actually different. They mean different things, which again just makes this command harder to use than it should be, which is unfortunate, but it's a reality. Okay, so the POSIX and Unix standards require that PS-AUX print all processes owned by a user named X, as well as printing all processes that would be selected by the A option. If the user named X does not exist, this PS may interpret the command. Anyway, weird stuff. And then notice it is fragile, subject to change, and should not be relied upon. So it's kind of a mess. Just heads up about that. The PS command is a bit of a mess. If you're a system administrator at some point and you're working in Linux, you will become a PS expert. We will just explore some of the most basics about it. Okay, so then a whole bunch more text. Okay, so here's some examples to see every process on the system using the standard syntax. There's a variety of ways to do that. There's the BSD syntax, process trees we could try, threads we're not going to worry about, security info. So notice there's just a bunch of stuff, a bunch of options. So we'll use -EF. That's one that I commonly use, -AX. Anyway, let's just see what some of these options look like. Let's start with -E and -EF, and then I'll come back to the man page. So there's PS, which by default just shows what processes are sort of immediately in my foreground environment running under my user. If we do -E, we get a bunch more stuff because we're getting information about all the processes on the entire system, not just the ones associated with my user. Notice, by the way, that it ran past the screen. So we will pipe that into less so that we can get a screen at a time and then move through it as we want. So notice the PIDs. They're pretty much counted straight up without any gaps until after number 66, I think. So what are all these things? These are the various pieces of software that make a running operating system. We don't have any of these as a concern of ours in this class. This is digging deep system administrator kind of stuff, which for some of you will be the second semester of this class if you take it. But just to note that a running operating system consists of many, many different running instances of small programs that do a variety of different things. There are things controlling the virtual hard drives, as an example. There's processes associated with our network connection, just a bunch of stuff. And then you can see down toward the bottom, you can kind of finally start to see things that are associated with me. So there's my bash 442, and then probably 481 and 482 are the two processes that I'm currently in the middle of as I'm viewing the all processes output. All right, so now let's try ps-ef and see if there are differences. Okay, there are differences, so let's pipe that to less and see what that looks like. So now we have the user ID on the left column. So that's the user that owns the process. So most of them, in fact, all of the sort of low-level operating system processes are owned by the root user. You see the PID column, which is the process ID. The PPID, the PPID, that's the parent process ID. So a lot of processors are actually started by other or owned by other processes as their children. And then we'll just scroll down until we start seeing me in there. So there's JBoydT. So there is a PID 436, that is a system D for me. 437 is an authentication module. 346 is something to do with my bash. And then, but what's interesting is the last two entries, 547 and 548, the parent is 442, and the parent is my bash shell. So I launched those processes from another process. I'm in the bash shell process, and I actually launched ps-ef and less as children of my shell. The important thing to note for you who are system administrators is that if you shut down a parent process, you also shut down all of the children processes. So if you are doing manual process control, you have to be careful that if you are closing down one process, you need to note what its children are in case the children, you don't want them shut down, and you have to deal with that. Okay, so there's those options using PS. Let's bring up the man page again. I'm just clearing so you can see more easily what I'm typing. So let's look at the manual page. And let's go down. All right, so here to see every process on the system, BSD syntax. So notice that we would use AX for something similar. Okay, a process tree could be interesting. So -EJ capital H. Let's try that. This is the Unix syntax with the dashes. I'll pipe it through less. I don't see anything. There is a group ID, a process, probably group ID. All right, the tree is not of any interest to us. So that's what that looked like. I'm in the manual page again. Let's see. Info about threads. I don't care about that. I'm not really interested in any of the rest of those. But let's try the one that said at the top that it was going to be weird. So -AUX. So let me pipe it through less. So this is basically all of the processes on the system with the user associated with them, and then a little bit of additional information, which I actually think could be handy, like how much. If you notice the third and fourth columns, percent CPU, percent memory. So these things are telling you how much of the processor and how much of the RAM's capacities are being currently used by these processes. So that first process, PID1, 0.4% of the memory. which is the only one that even registers as using any resources. Here's a few that, so you can see down toward the bottom, PID 186, 0.6% of the system's memory. That's a file system kind of thing. There's some long lines in there. So I'm just kind of scrolling around down and just looking at the information that are being shown. What is that column? VSC. I don't know what that is. I have to look that up. Start. So anyway, -AUX is actually all the processes on the system, but with actually more information than those other options that we used. So I think I asked a question about that because this is the view all processes on the system that I tend to use. Okay. So a process is an instance of a program running on the system. And there are a lot of instances of a lot of programs running on the system right now just for the system to be up and running at all. What's most interesting to us is the fact that even my user has processes running. My shell being my primary process, and then whatever commands that I run, those are also processes. And there again, notice PS has a new PID because it's a new instance of the process every time I run it. Every time I run PS, it's the same old bash, but a brand new instance of PS had to run. Okay, so let's add another command, which is the kill command. So you may or may not want to do this alongside me because it can be inconvenient. But so the kill command is used to control processes. It's unfortunately named as kill because the kill command does more than just kill processes, but 99+% of there's a sound outside that's distracting to me. Hopefully you can't hear it. Anyway, the kill command is used to control processes. And you just have to get that straight in your head. And in fact, more specifically, the kill command is used to send signals to processes. So we use the kill command to communicate with processes. Usually, and most 99+% of the time, when I use the kill command, the signal I am sending to a process is that I want that process to shut down. So I almost always use the kill command to kill processes in the way that I think of that, what that means. But technically the kill command is used for sending signals to processes, and those signals don't necessarily have to be shut the process down. Also confusing, right? But I'm just going to start with the most basic kind of kill command, which is I'm going to try to kill my shell. So there is a variant of kill that we're not going to use in this class because I want to learn the sort of basic traditional one. But anyway, what I'm saying here is, for all intents and purposes, I want to shut down my shell command, my shell process. So let's see what happens when I do that. All right, so in this case, it just flat out ignored me. And that's a good thing because I will run a variant of this kill command to send a signal to my shell that I don't want to be ignored. I want to shut it down. So one thing to note here is that the kill command sends signals to processes, and those signals might be ignored. There's a way that you run the kill command so that it can't be ignored, but in this case, it did not actually kill that process. So I make note of that. So let's go look at the manual page for kill. So notice that it says send a signal to a process, which is confusing because it's called kill, and that makes us think that it's designed entirely to shut down processes, and it is not. That is what I almost always use it for, is to shut down a process, but it can be used to send other signals as well. So the default signal is term, T-E-R-M, and that's the terminate signal. So that is the shutdown signal. So what it's saying is that if you run the kill command with no options and give it a PID, notice the synopsis, it will send the terminate signal to the process. The reason why it's important to note that this is sending signals is because signals can be ignored by processes. So I just sent the terminate signal to my shell and it ignored me. So we can send different signals, and we should also remember that those signals can be ignored by processes, except for one signal, which can't be ignored. So particularly useful signals include hup, which means hang up, int, which is interrupt, kill, which can't be ignored, stop, continue, and 0. Alternate signals may be specified in 3 ways: by a number, by the name of the signal preceded by sig, that's signal kill, or just the word for the signal itself, which is kill. So this is a confusing one. What does kill do? It sends signals to processes. What are those signals most of the time? They are signals that are asking the process to shut itself down. Does the process have to respect the signal that it is receiving? It does not, with the exception of kill, which it cannot ignore. So -9, -sig kill, or -kill actually will force the process to shut down whether or not it wants to. So let's try that instead, and then we'll come back to the man page. So again, what's going to happen here is I'm going to get, so I'm going to send the kill signal to my shell process. And this is different from the term signal. Well, so this is the default is term, and it's being ignored. The kill signal can't be ignored. So what happened when I killed my shell? It forced me to log out for all intents and purposes. If I don't have a shell associated with a login session, then I'm not logged in anymore. So I'll log back in. I will note that the PID for my shell has changed because this is a new instance of it. I killed the other one. Okay, so the thing to note there is that I use kill to send the terminate signal to my shell and nothing happened. Why? Because it ignored it. So processes can ignore signals except for one of them, which is the kill signal, which I will spell as sigkill this time, which is one of the alternatives. So this signal cannot be ignored. This signal will guarantee that whatever that process is shuts down. So you have to be very careful with this signal because if you send it to the wrong process in your operating system, you might cause the whole operating system to bomb on you. So be careful with it. But if you send kill to your shell, kill cannot be ignored. And the effect of it, at least for now, is that it logs us out. So I'll log back in and note that I have a new PID for my shell because this is yet a different instance of it. Okay, so killing is sending signals. It's not always killing, meaning shutting down the process. There are different signals. Let's use a variant of kill, the -L option. So kill space -L. And we can see what all of the sort of database of signals looks like. There's a lot. These are not things that system administrators use a lot of. Programmers use them. System programmers use them more than administrators. But system administrators and even developers who are, running their own web servers for development purposes, that kind of, or databases, will use some of these signals. So what we're seeing here is the number code associated with each signal, the full kind of signal name of the signal, and then the signal name after sig. So signal number 1, which we could say kill space -1, is the hang up signal. We could also send that sig hup as -1. We could send it as sig hup, or we could send it as hup. Let's see what happens if I send that to my shell. It caused it to shut down. So I have 2 different signals that the shell is interpreting as shut itself down, hang up and kill. Although in the case of term, kill space -l, in the case of term, which is signal number 15, the shell is ignoring it. So if I try to send 15 to my new instance of the shell, it ignores that, right? Or I could send it as sig term or as term, and it's ignoring that particular signal. If you have a little bit of programming exposure, these signals come into the software and then get themselves into a decision tree. So the software can say, if I receive a signal and that signal is sig term, do this, which for the shell means do nothing. Else, if I receive a signal and that signal is sig hup, then do this, which in the case of the shell includes at some point shutting the entire software down. So don't get too hung up on all of this stuff. But do try to understand what a process is. It's a running instance of a program, and there are a whole bunch of them. What the kill command does, which allows us to send signals to those processes. And then what are the signals? The most important ones to us are the kinds of signals that allow us to manually shut down a piece of software if for some reason it is misbehaving, or just for any reason we need to shut it down and have no other way of doing it. And we should note that when we send a signal, it may be ignored by the process that's receiving it, or it may be received by the process and then cause different things to happen, like the software shutting down, and there's some other possibilities. Okay, so that's a lot of stuff. Let's go back to the man page for kill and see if there's any other interesting details in here. So we did the -L option, which is list the signal names. The -L is list the signal names in a nice table. Capital L, that's the same. Okay. I guess they both do a nice table. I'm disappointed. Okay. Your shell may have a built-in kill command. You may need to run the command described here as bin kill to solve the conflict. Let's try. Which kill? No, that's the right one. So okay, anyway. And then there are some variants you can see down here. So kill all, nice, p-kill, re-nice. Those are more advanced, for the most part, system administrator kind of stuff. For us, just to get the basic introduction to, we can view processes, and we can use the kill command to send signals to those processes. Most of the time, our intention when we send a signal to a process is to get it to shut itself down. And that is because when we use the kill command, it will be because we don't have, we may have no ability to access the running process through our shell. So the only way to get to it is by killing it with its process ID. Okay, so that's the kill command. Oh, Control C, right? So I'm gonna use one of my favorite commands for doing this. So I'm going to use the sleep command because it's such a convenient way of exploring processes and process control. The sleep command basically is just a program that runs and does nothing for a certain amount of time. And that's great because we can tell the sleep command to run for a very long time, and then it gives us plenty of time to think about what happens next. So if I say sleep 3 as an example, basically nothing's going to happen for 3 seconds. And then the sleep command is done and we get the prompt back. So the sleep command is super, super useful for all of the rest of the things that we're going to talk about today. The first one is if we have a running process and it is in control of our shell. So you notice I have no command prompt anymore. And I have a command running and it's going to run for a very long time and I want to stop it. I can do control. So I'm holding the control key down and I'll press C. And that killed the process. So Control C is actually a keyboard shortcut for sending a signal, and I will leave that as one of the things for you to find. In your reading, and then you'll be asked about it in your lab questions this week. Control C is a keyboard shortcut for sending a signal. In other words, for one of the kill options for that process, the controlling process. I'll do it again. So if I run, so there's no sleep running. So if I do sleep 3000, let's just say. So sleep has taken my command prompt away from me. It is controlling my shell. And I can send it signals with keyboard shortcuts if I need to get my prompt back. So Control C will typically terminate, hint, hint, the process that has taken my prompt away from me. And if I run PS, you'll notice there is no sleep. Okay. Control Z, I should have moved that. Let me move it down because that's going to make more sense down here. Let's see. Let's put it right here. Okay. So Control C is a keyboard shortcut that sends a specific signal. And we use Control C to send that signal in situations where we don't have a prompt where we can actually type a command. So if I run sleep 1000, notice that I don't have my prompt anymore because this is sleep 1000 controls it unless I change the status of sleep 1000. So if I just want to terminate it, I'll do Control C, and that will send a signal to the sleep process that had taken my terminal away from me. And now I have it back. And we'll notice that the sleep process is gone. It shut itself down. Okay. Now, the part that I think is actually even slightly more confusing. We just need basic definitions and basic understanding in this class, so don't get hung up too much on the gory details in this class. In a second semester System Administrator Linux class, you will get more of the gory details of process control. Okay, so now the next part, which is jobs. So what is a job? When does a job happen? And how do you interact with jobs? So jobs is the shell. And in fact, I'm going to enhance my notes for that as well. Processes are the OS. Jobs is the shell. So process is an instance of a program running in the operating system. A job is a process that is being managed by the shell. Let's see if we have any by running the shell's jobs command. So we have no jobs right now. So we are presently not using the shell to manage any of our processes. Now this part is a little bit weird at first, but it's super, super cool. So it turns out that the shell gives us some sort of next level ability to interact with our processes. And I'm going to show you one right now. So take that sleep command. If I type sleep 1000, let's do shorter. Let's do sleep like 30, so it'll go away on its own sooner. If I were to hit enter right now, I would not have access to my command prompt again while that sleep is running. Now, I know sleep is not the best example for the real world, but it is a great tool for experimenting with process and job control. So if I run sleep 30, I'm going to be sitting here waiting for my command prompt to come back 30 seconds from now. However, I can run my sleep command in the background. And this ampersand at the end of the line means run this process, but run it in the background and note the difference. So that sleep process is now running in the background, and because it's in the background, it still continues to execute. That right there, that list is showing me its PID. So it's executing, but I get my terminal back. So I can do other stuff in the meantime, you see, while the sleep command is running, and I will use PS to prove it. So there's the sleep command. It's PID 759. But when I backgrounded it, I also made it something that the shell is taking care of for me. So when you background a process, you get your terminal back, and you are also taking advantage of the shell's process control mechanisms, its job control, to allow you to do that. So I hope this makes some kind of sense. There are times when you want to run a command, let's say a compiler command, or some other kind of command that you know is going to take a long time to do its work. And you want to continue working at your prompt while that command is still out there executing. Well, the way to do that is to background it, give the shell job control over it, background it, and then you get your prompt back. So let's do a longer one so that we can see that again. Let's look at jobs. All right, so presently there are no jobs. Why? Because the sleep command that was going to sleep for 30 seconds, the 30 seconds ended and the sleep command went away. So let's do a longer one so we have more time to think about it. So remember, if I run it in the foreground, this is called the foreground, the sleep command has control of my console, and I can't type further commands right now. So I'm going to Control C to send the terminate signal to it, which causes it to terminate in this case. And I'm going to run it instead in the background. So running it in the background is really telling my shell, please execute this and keep it executing, but give me my prompt back. And in doing that, I have created a process 765. It's an instance of a program running on the operating system. And I also now am using the shell to manage it as a job. So I am managing it as a job, meaning that the shell is guaranteeing that it will continue processing for me, but let me have my command prompt. So there it is, it's running. It's still running. It's going to be running for a long time. So let's see where, yeah. So let's actually put foregrounding first. So if you have a job running, like I do number 1, and you want to bring it back into the forefront, into the foreground, you can actually type FG, and the shell will give that process. So I'm using job control. So now it's foregrounded the process. And now the process will continue running, but in the foreground now, which is what it's doing right now. So foreground means the process has control of my console and I can't type commands. Background means that the process is running, but I get my command prompt back. Good one. So that one kid asks, can you kill jobs also or just processes? And the answer is you can kill jobs and processes. So let's do an example of that. So you can use kill to kill a job, meaning you can sort of work through the shell's job control to kill something. And you have the option of killing it as a process. So let's kill this one. We'll list jobs, no jobs. So let's start a new one and then let's use jobs to kill it. In fact, let's run a couple of them. So let's run a 333. So it'll be easy to see. Let's run it for a super long time. Background it. And let's run a 555. And these are just numbers. It's going to be sleeping for 3,333 seconds unless I do something about it, right? So, and then sleep 5555, 5,555 seconds. The reason why I use those values is so they're easily recognized when I work with them. All right. So now I have both of those processes and I can kill them as processes. Let's do another one. So let's kill the 555 one, which is 769. So I can kill 769. Usually when I'm using kill, I will accept the default terminate on the process and see if it goes away. So let's see if that got it. That got it. I'm going to list the jobs. Okay, so now I have jobs 1 and jobs 3 running in the background. So the question was, can you kill jobs? And the answer is yes. And the way you do that is you do a jobs listing and then you use the % sign and you say, I want to kill job 1. So if you use the % sign, then you need the job number that the shell is attached to it. Let's list the jobs. So notice that the shell has terminated it for me. And if I do a PS listing here, I will see that the only command left is that last one, which is the 771. So great question, that one kid. You can, in fact, kill jobs or processes, just depending on which view you wanted to take of it. Which is, yeah, it is very cool. I quite like it. So there is that last job, which continues running. So notice its job number is 3. So they don't kind of bubble up the jobs list until the jobs list has been empty. So let's kill that one from here as well. And then if I run jobs immediately, it'll say, okay, that one's been terminated. I won't see it in the process listing and I won't see it in the jobs listing anymore because it has been killed. Quite cool. Okay, so let me check my... lost my mouse. Yeah, it's a very cool thing. I like it a lot. So there, that answered the kill question on jobs. Thank you, that one kid, for the awesome question. So now let's see what Control Z does. So let's do a super long 1, 2, 3, 4 sleep. And I'm going to run it in the foreground. And then I'm going to do Control Z. So Control Z sends a signal, and the signal is that it actually stops. It doesn't kill the process. It just kind of stops it in its place. So it's not currently executing. It's just sitting there under the shell's job control, waiting to be restarted once I choose to do that. So I'm going to foreground it. In fact, no, let's background it first so you can see that. So a stopped job means it is not even executing. It's in the background because I have my prompt, but it is not even executing. So if you background it, by the way, background will take the top item in the list. So if I say background now, BG, let's see what happens. So what background does is say, take that stopped job and start it running in the background. So I have my prompt back, which means that's, so notice it was stopped. Now it's running. Pretty cool stuff. I can foreground it. I can Control Z, stop it. If I foreground it from here, it'll probably just come in the foreground and start running again. Yep. Stop it. Background it. Foreground it. Terminate it. So these are the kinds of experiments that I would encourage. Is you can fire up a whole bunch of sleeps with very large numbers, and then you have all the time in the world to kind of go explore how these different things work. What does foreground FG do? What does background do? So foreground is a job control command. It takes the top item on the list and returns it to the foreground in execution. Backgrounding will take the top item in the jobs list that's if it's stopped and continue its execution in the background. Let me run a whole bunch. Give them in the background so we can also target. So 5, 4, 3, 2, 1 in the background. 1, 2, 3, 4, 5 in the background. So I have all these jobs running. So let's foreground. We can use the % sign to target something other than the top item in the list. So let's grab item number 2. Which, by the way, the minus is a shorthand for number 2 in this case, and the plus is a shorthand for number 3 if you see in the little listing. But anyway, we're going to foreground job number 2. And notice it's 5, 4, 3, 2, 1. That's correct. I'm going to stop it. So it's stopped, but the other 2 are running. Let's foreground job number 3 and stop it. Let's kill job number 1. And the shell will give me in the next jobs listing the fact that it has been terminated. But if I run it again, notice, okay, it's just gone. So my current list of jobs, both of those are stopped. So let's restart job number 3, but in the background. So it's running again. Let's restart job number 2, but in the background. So it's now running again. And if I want to, I could come in through the PS command and I could kill them like this instead. So now I've kind of gone around the shell's job control and I'm using the operating system directly. And now if I look at the jobs, I will see that, oh, something terminated what was job number 2. And then I will, if you foreground without a number, it'll foreground the thing that's top in the list. And then I'll Control C to terminate that. So I started going a little bit fast because I'm trying to be mindful of your clock and my clock. So there's a whole bunch of job control stuff. I like the sleep command for this because you can set these large values. It gives you plenty of time to think about what you're doing. If all else fails, by the way, so let's just say you have a whole bunch of things running. Let's just say you got a whole bunch of things going. You think to yourself, oh no, I don't know what to do. What do I do? Well, one thing you can do is simply exit out of the system. And that will take all of your processes with it, I believe. Yeah. So if everything feels like it went haywire, simply exit. And it should, it'll exit out of your shell, which will exit out of all the shell's child processes, which was all that CRUD that was running. And of course, you can always click on the X at the top left of the screen in a worst case scenario. Okay, that gets me in just in under an hour. I know that these concepts are probably some of the more difficult ones that we've dealt with. So reading can help, of course, for those of you who are kind of oriented to the definitions. But I still think that the best way to feel some comfort with PS, kill, and job control is to experiment with them a lot. Run just a whole bunch of sleep commands with very large values that give you tons of time to think about what you're doing and view the jobs list. We just barely kind of looked at the different things you can do with jobs. But they are plenty enough for our current set of experiments. So I'm going to change my view one more time. Actually, you won't see that unless I let you see it. Okay, so my closing comment is the hands-on experiments are reminding you to try out all those commands. And then at the bottom, I'll blow it up. At the bottom, you can see, you can, if in doubt, just do exactly what I did here. I ran a sleep 600 in the background, a sleep 300 in the background. I ran jobs to see that the shell is now managing those as running jobs. I did a process listing. I do a kill-9, which is a terminate on a process, and then do another jobs listing, and so on and so forth. So just a short series of experiments, but the more you do, the more comfort you will feel about these things. It is very powerful functionality. And I do use it as a developer sometimes, and especially the system administrators in our group, you will find, I hope, a lot of interest in learning about and using the utilities in Bash to control jobs and processes. It's fun. It's very interesting. At least I think it is. Okay, that's where I'm going to stop. Review for midterm next week. This is the last content that goes into the midterm. So weeks 1 through 8 go into the midterm. The questions are all drawn as random selections from the first 8 weeks labs. So that includes this week's lab. But I'll go over all of the stuff that the midterm will cover as a review on next Monday morning. Other than that, I hope you have or are having, if you're watching this later, a good week. And I will see you at 8 on Monday next week for the midterm review. So have a great week.